Now we want to be able to write the equation of a circle if we're just given the center and a point on the circle. Okay. And so it says write the standard equation of the circle centered at the origin and containing the point -2, 3. So here's our center. Okay. Remember that the origin. So our center is HK, and that's the origin, which is 0, 0. And we have this other point, -2, -3, or -2, +3. And so in order to write the equation, remember we need the center and the radius. Okay, so in order to find the radius, we are going to use the distance formula. Okay, so we are going to use the distance formula to find the radius. To find radius. Okay. And so our radius is the distance between those 2 points. So radius is equal to the square root of, and we've got, remember the difference of our x values, so -2 minus 0 squared plus the difference in our y values, 3 minus 0 squared. And now we can simplify this, and we get -2 squared plus 3 squared, which is equal to square root of 4 plus 9, which is the square root of 13. Okay, so that is my radius. Okay, so radius equals the square root of 13. Okay, so r square root of 13, and then center is 0, 0. And our standard form of the equation is going to be x minus 0 squared plus y minus 0 squared equals the square root of 13. Remember, squared, the radius squared. And so we can simplify this, and I can just say x minus 0 is just x. X squared plus y squared equals 13. And that is the equation of a circle centered at the origin and going through the point -2, 3. Now, keep in mind, any circle that's centered at the origin is just going to look like x squared plus y squared equals radius squared. So this gives us a little note here for any circle centered at origin. The equation is going to be in the form of x squared plus y squared equals radius squared. Okay, and that's just a special case of our general formula. But notice, if you see that, all that means is that your circle is centered at the origin. We want to write the standard equation of the circle centered at -1, 3 and tangent to the line y equals 2. Okay. So first, it's easy enough for us to identify, here's the center of the circle, at negative 1, 3. Okay, so that's our center, negative 1, comma 3. And now it's tangent to the line y equals 2. Okay, so if something is tangent to another object, that means it touches that object at a single point. Okay, so this is going to, what this is going to be is it's going to be a line, okay, at y equals 2. So let's see the line y equals 2. Let's move this out of the way. So negative 1, 3. And that means it's tangent to this line y equals 2, which is going to be that dashed line there. So that's the line y equals 2. So that means that it touches, okay, the line. So if this is a line, it's going to touch just at that point. Okay, so that is a point on our circle, which means that since a circle is a set of all points equidistant from the center, if that is a point on the circle, then this distance here must be the radius. Okay, and so our radius then is this length here, which we can see is a distance of 1. So our radius is equal to 1, and our center is at negative 1, 3, so we can write our equation. So x minus a negative 1 squared plus y minus 3 squared equals 1 squared. And we can clean that up and say x plus 1 squared plus y minus 3 squared is equal to 1. And that is the equation of the circle with that center given that radius. Now, with all of these circle problems, it's a little more cumbersome to graph it on the graphing calculator. Okay, there is a way, and you can probably search for that online. Okay, but the easier thing to do would be to check your work in Desmos. So you could go out to Desmos and check this graph and see if it corresponds to the picture you think it should. So that's how you can find the standard equation of a circle.